So compression is pushing and tension is pulling. Another effect of loads on a structure is called shear. Shear is sliding. It's the action of dividing a material along a very thin plane that's parallel to the opposite forces.
Now, what on earth do I mean by that? Well, it's really the basis of the cutting action of a pair of scissors. Look at this pair of metal cutters. If I open them, there are the two blades, of course, and I can run my finger along them and nothing happens. They're not sharp at all. But I can cut this piece of metal and I can cut this piece of paper. So how come they're not sharp enough to cut my finger, but can cut through paper? Well, it's not sharpness per se that's the important thing. It's really how closely the two edges of the blades are touching. The closer they are together, the better they can shear something. Let's take an expanded view of what's happening as the edges of the two blades come together.
When we blow up the picture, you can see that the two cutting edges are pushing against the two sides of a rectangle. They distort that rectangle into a shape we call a parallelogram. Look at what's happening to the material within that parallelogram. Let's just draw in the two diagonals from corner to corner. There. When the form was a rectangle, before we started to close our shears, both of the diagonals were the same length. But now, as the shears close and the shape becomes a parallelogram, one of the diagonals shortens. That's compression. And the other lengthens. That means tension in the material. So in fact, when we use the shears, we put the material under both tension and compression. They are acting at close to right angles to one another in the material and as much as 45 degrees to the cutting action of the shears. And believe it or not, that is why the paper or the metal sheet is cut. What does this have to do with buildings? Well, shear is the force on these rivets as the two sides try and move in opposite directions. This is a time when shear works against us. It sets up the same pattern of tension and compression inside the rivet that we saw when we cut the metal with the shears. So we fight it by making the rivet so tight that the rectangle becomes very, very small and the rivet can't shear. Our next example of a force from